Welcome to aminacademy.com. In strength of material, we'll discuss about shear force and bending moment for cantilevers. Here, we'll discuss shear force and bending moment diagram for a cantilever with a point load at the free end. Look at this figure. Here, this is a cantilever fixed at one end and free at other end, and load W is acted at one end. Now consider a section XX which is x distance from free end. Now the cantilever here is A, B. The length is L meter. Now let Fx equal shear force at X. At point X. Now also Mx bending moment at X. Take a section X at a distance X from free end B. Consider the right portion of the section. This is the right portion of the section. This is the left portion of the section. The shear force at this section, that is right section, is equal to the resultant force acting on the right portion at the given section. But the resultant force acting on the right portion at the section X is W. This load W is acting, which is acting downward, is considered positive. We are considering the load acting downward is considered as positive. Hence, the shear force at, therefore you can tell Fx shear force at right section equal W. We can put it's a positive W. Now the shear force will be constant at all section of the cantilever. That means the shear force is constant at all section of the cantilever AB. The shear force diagram will draw now. Therefore, it's a, we will write with some scale. Suppose this line here, you have to write vertical line for some scale for the W. Now this is it's a constant everywhere. Shear force is constant throughout the cantilever. So we have to draw a rectangle like. Here this is from here to here is W. This is a considered positive. Actually, this is the baseline. and we can keep this much is W for some scale. Now let us discuss about bending moment. The bending moment at section XX at section XX is equal, that is mx equal minus w into x distance. Bending moment is always the load into the length. So from right side portion of the xx we are considering as a negative, then w into x distances. Bending moment will be negative as for the right portion of the section. The moment of w at x is clockwise. The moment of x is clockwise, so we are considering it's negative. Also, the bending of cantilever will take place in such a manner that the convexity will be at the top of the beam. Here, due to load at one end for the cantilever, the beam tends to convex. That means it bend like from upward. Now, for this, we'll calculate that bending moment at every section. We'll do first at x equals 0. At x equal to 0 means at x equals 0 here, at x equals 0 bending moment Bm equal to 0. At this section from right side bending moment is 0, and at x equal to L, at x equal to L means this full length, the bending moment equal W load into length. Hence, the Bm follows the straight line law, that is straight lines linearly varying. Then bending moment diagram is shown in figure. For this, we'll draw bending moment for this cantilever beam like here. Suppose draw a baseline. Use red for this. This baseline. Now we have to take a point. The bending moment is maximum at this section because it's a fixed section. So for some scale, we take this is W and L. Suppose this point is here. Now from this point, this bending moment is 0 at this point. So we have to join these points. This is our shear bending moment diagram. It's negative we are keeping. The point B, the point A. Here the baseline. From the baseline we are drawing downward. This is the method for drawing a bending moment, shear force and bending moment diagram when the load is at one end. We have done. Please subscribe our YouTube channel.